Hello class, welcome to today's lesson in which we're just gonna take a look at the concept of acceleration. Remember, what have we seen so far in relation to kinematics? Remember, what was kinematics? It's the study of motion itself. Kinematics doesn't study the causes of the motion, right? And we have seen a lot of things. Motion is relative, what the system of reference is, what a particle is, distance and displacement, very simple concepts. And then we studied speed and velocity, which was the last thing we saw. And right now we're gonna take a look at acceleration. So what is acceleration, guys? The main concept is extremely easy. The acceleration is just a change of velocity. So whenever you change the velocity, either walking or running or inside your car or etc., whenever an object changes its velocity, then we say that that object is accelerating. So it's a very simple concept. Now, what is the precise definition? Well, the average acceleration is defined as the change of velocity of the particle divided by the change in time. And let me tell you what that means in a formula. So we usually write the following, guys. We're gonna write average acceleration equals the change of velocity. I'm gonna write this weird symbol. It's like a triangle, and this is read change of velocity. I'm gonna repeat change. This little triangle is read as change of velocity over the change in time. That is the definition of the average acceleration. And let me tell you how this little symbol here works. This little symbol, guys, in mathematics and in physics is read as change or change of. Change of what? Whatever variable you have next to it. So this is change of velocity, change of time. If I represent x with, if I represent distance or position with an x, then this would mean change of position. If I represent height with the variable h, this would mean change of height, and so on. And the formal definition of this symbol is the following. It's basically the final quantity minus the initial quantity. What quantity? Whatever quantity you have next to it. Okay? For example, guys, let's suppose that right now I have a clock on my hands, and right now it marks 15 seconds. Okay, and then sometime it's gonna pass, and right now it marks 20 seconds. Okay, so a moment ago it marked 15 seconds, my clock, and later it marked 20 seconds. Okay, so if I asked you what was the change of time between this and this instant, what you have to, you know that the answer is 5 seconds, right? That was the change in time. But let's apply this definition. This symbol is final quantity minus initial quantity. What was the final quantity in this experiment? This was the final quantity. So that's gonna be 20 seconds. And what was the initial quantity? It was this one. So minus 5 seconds. And you will get minus 15 seconds, I'm sorry. You will get 5 seconds, right? So the change of time was 5 seconds. That's how this symbol is used. And if you didn't know, this is actually a letter in the Greek alphabet, and it's called delta. It's the fourth letter in the Greek alphabet, delta. So that's what it means. Change of velocity over change of time. That's what acceleration, that's what the average acceleration is. Now let's see two examples of what I mean by this. Let's calculate the average accelerations of two motions. So this one, exercise number 7, it says a cyclist starts from rest and then after 3 seconds, she's traveling at 21 meters per second. Find her average acceleration. Okay, so let me write first the definition of average. I'm abbreviating average. Average acceleration. By definition, that's the change of velocity over the change of time. And each of these things, each of this and this, what that means is final velocity minus initial velocity over final time minus initial time. So let's see first what are all of these quantities, guys. This, and this for my specific motion. What was the final velocity? The final velocity is 21 meters per second, right? That is the final velocity of the particle. What is the initial velocity of the particle? Well, since it starts from rest, what that means is that its initial velocity will be 0 meters per second because it starts from rest. Now, what was the final time? Well, first I need to decide at what time I'm going to start measuring. For example, all I know is that after 3 seconds, she's traveling at 20 meters per second. So I can write that the initial time was 0 seconds, and therefore the final time would be 3 seconds. You see? But I also could have done this, and it would have been just as good, like 4 seconds and 1 second. If I start observing the phenomenon at 1 second, and then after 3 seconds we will have 4 seconds. So either way, it doesn't matter whether you follow this approach or this approach, it doesn't matter. Of course, this one is much simpler. So that's it, guys. We have all the ingredients to calculate the average acceleration because we have all of these quantities involved in this division, right? So let's substitute. Final velocity, 21 meters per second, minus the initial velocity, which is 0 meters per second, over final time, which is 3 seconds, minus the initial time, which is 0 seconds. Let's calculate all of this. We're going to get 21 meters per second over 3 seconds. Let's divide 21 over 3. That's going to be 7. And let's divide meters per second over second. And you will get meters per second squared. Let me explain to you why you get this weird unit, like second to the square. What is the reason why we get this unit? Okay, what you need to understand, guys, is that we are dividing all of this over this. So let's do that over here. I'm dividing meters per second over seconds. This is what I'm doing. Now, in order to carry out this division, I can help myself by writing a 1 below these seconds, right? Because if I divide anything by 1, it doesn't really get affected. So I can write this meters per second divided by seconds over 1. And then you apply the rule of the division of fractions because that's what we have here. We have one fraction being divided by another fraction. So you multiply m times 1, and that goes above m times 1 over this times this, the two quantities in the middle. So it's going to be seconds times seconds. And if you notice, I'm going to continue over here equals meters times 1, that's going to be meters, and seconds times seconds, that's going to be seconds squared. And so as you can see, guys, the units for acceleration are meters per second squared. like that. So this is the answer, guys. That is the average acceleration for this particular cyclist. And how can we interpret this value, guys? What does it mean in simple words? Well, what it means is that on average, during this motion, this cyclist was increasing its velocity 7 meters per second each second. I'm going to repeat that. In this motion, this cyclist was increasing its velocity 7 meters per second each second. That's what it means. Let's do the next one. Exercise 8. It says a car is traveling at 100 kilometers per hour and then suddenly applies the brakes, coming to a stop in just 2.5 seconds. Find the average acceleration of the car. Same idea. What is my definition for average acceleration? Average acceleration. That is equal to the change of velocity over the change in time. And each of these quantities, what they mean is final velocity minus initial velocity over final time minus initial time. And if I know each of these four quantities, therefore I can calculate the average acceleration. So let's find that out. What's going to be the final velocity, guys? Well, the initial velocity is 100 kilometers per hour, right? Because that's what the problem tells you. The problem tells you that a car is traveling at this velocity initially, right? 100 kilometers per hour. And then it tells you that the car applies the brakes and it's going to come to a stop. So what that means is that the final velocity of the car will be 0 because it's going to come to a stop. So there you have. We have the final velocity and we have the initial velocity. What about the times? What is the initial time? Again, we can decide that it's going to be 0 seconds. And then after 2.5 seconds, it's going to arrive at 0 kilometers per hour. This is the time it's going to take the car to completely stop. 2.5 seconds. That's kind of quick because it was going very fast. And that's it, guys. We have all the ingredients to calculate the average acceleration. So final velocity, that's going to be 0 kilometers per hour minus initial velocity, which is 100 kilometers per hour, over the final time, which is 2.5 seconds, minus initial time, which is 0 seconds. Let me simplify each of the numerator and the denominator of this fraction. You're going to get minus 100 kilometers per hour over 2.5 seconds. And as you must see, we have different units, right? We have hours and seconds in here. So we need to convert either this or this. Okay? Let's convert this to meters per second. Okay, let's convert minus 100 kilometers per hour to meters per second. Let me take my calculator. That's gonna be 27 minus 27.7 meters per second over 2.5 seconds. And now I have the same units of time. Remember, you always have to have the same units of time or of length. Okay, so remember that, guys. And let's just divide this number over this number. That's all we need to do next. And you're gonna get minus 11.08 meters per second squared. Remember, we're talking about acceleration, so the units of time should be squared. And this is the average average acceleration. That's it. Okay, so what does this mean again? It means, guys, that during this motion, during the braking period, the car was decreasing decreasing its speed by 11.08 meters per second each second. Okay, it was decreasing its speed. Okay, guys, so that's what acceleration is. It's just basically a change of velocity in a given amount of time. You need to divide by the amount of time that it takes to perform such a change of velocity. Okay, it's the change of velocity over how much time it takes for that change of velocity to occur. Okay, and it's that simple, guys. Okay, now you're gonna do two exercises from the book, and let me go there with you for questions. Thank you, guys.